Hello and welcome back to Cracking the Cryptic, especially if you've been led here by having watched our most watched video, which is doing another 25,000 views a day somehow now. I don't know why that keeps happening sometimes, but that incredible magic square puzzle by Ard still doing great business. So if you've been led to the channel by that, Simon and I post a video each every day at the moment, and have been doing since our first lockdown in March. And we've got all the way virtually till Christmas. Well, we've got to the winter solstice, and today a big winter solstice puzzle. No, I'm joking. It's another Christmas tree, clearly. This one came in from Gert Hana, who said in his email, he used the word approachable. Now, unless that was in a doctored email that Simon sent on to me, let's hope Gert's telling the truth about his own puzzle. It is a thermo Sudoku. That is a fairly simple rule set. This time we can ignore the colours, not like yesterday where the greens and whites really mattered. Here the colours are for decoration only, to show the image of the Christmas tree. And very pretty it is too, with the bulbs highlighted in yellow as they're sort of candles on the tree, I think. So the rules, as always with thermo Sudoku, normal Sudoku rules apply, and along thermometers, numbers must increase from the bulb. So this number will be lower than this number, which will be lower than this number. And the numbers must increase here even when they change boxes. So that's what we've got going on. It looks like a classic Christmas tree puzzle. Let's do have a go on the link below the video. I mean, if this is approachable, great one to cut your teeth on, and to learn some of the Sudoku, some of the thermo Sudoku techniques with. Just before I start, I will of course mention our apps, which are available on the App Store, on Android and on Steam, and are proving very popular. And of course there's extra content on Patreon. Right, on with the motley, and let's get cracking. So we've got, it looks like the longest thermo is this one. 1, 2, 3, 4, 5, 7 cells. So we deduct that from 9. Oops, that gives us 2 degrees of freedom. So as well as the minimum number, I'm putting 2 more in each cell to show what the possible candidates for each cell are, for the numbers to keep increasing, and it must be the case. And it's just occurred to me now to look at this central column. I was going to go where is 9, but there are 2 possible thermo ends. But this is a useful technique, and look at the central box. Where is 9 in the central box? If 9 is on a thermo, and every digit on that in that central box is on a thermo, it has to be on the end. So this one must be the 9 in the central box. The trouble with that is, it's brilliant. It looks like it gives you a great answer, but the oddity is that you can't then use that to limit the other thermo numbers at all, because as a maximum it doesn't do much to the rest. Anyway, enough theorizing. What else? Where are the next longest thermos? The others aren't actually very long. 1, 2, 3, 4, 5 cells. Okay, so maybe this time, I would often just go at this pretty much filling in everything, all the possibilities, but actually you'd end up with an awful lot of candidates in this grid if we went about it that way, so I'd rather not if possible. Now 1 in this box cannot be in any of those cells, so 1 has to be down here somewhere, and I'll use the corner pencil marks to show a group of cells within a box where a digit is confined. Now that means that the 1 in this box has to be on a thermo, and just as 9 can only be on a thermo end, 1 can only be on a thermo bulb. Now we can move on to this box. Where's 1 here? Again, on the only bulb available. Therefore it's got to be on one of these 2. We don't know which one. But we do know in this box now, because actually we knew ever since we pencil marked those 1s. If I'd looked at it, we can put a 1 in here. That's giving us some 1 possibilities at the top, but there's quite a few of them, so not all that helpful. Now, The fact that this can't be a 1, is that helpful? Not really. Its thermos are not very long, so even though that has to be at least 2, they would have to be 3 and 4, but these could be 4 and 5 at a minimum, and that could still be only 5. That's not the kind of information that's going to tell us enough. So what else can we do? Right, 9 in the top box. That 9 is ruling out those 3 cells. This one, well, I mean, the thermos rule out those as well, but the thermos rule out those because they're not on the ends of a thermo. So 9 must be somewhere in the top row there, therefore in one of those 3 cells. Is there any other places where that's useful? Not really. This can't be 9. 9 in the bottom box then. Yeah, because we've got the 9 there now. 9 in this box 8 has to be in one of those 2 cells. Can't be on that thermo end, and it can't be anywhere else on a thermo. Now, that, yeah, that does work in box 9, because now that 9 is in one of those positions, it can't be there. This 9 means it can't be on those thermo ends, so it must be on this one, which looks the most useless thermo in the world, 1 at the start and a 9 at the end, but at least we've done it now. 9 there. The 9 in row 7 has to be here as well. So that's going okay. We could take out the 9 as a possibility up here because of that one. But we don't know in box 4 at all. Or really in box... Oh, yes, we do know in box 6 because we've been given a 9. So 9 now has to be there and in one of those 2 cells. So we're left with this little X-wing on 9s on the right, and another X-wing actually at the top and bottom of the grid in columns 4 and 6. Okay, that's not bad. Now, I was just wondering about 3 in this box, given that 3 is ruled out of those cells, but it could just be here. I was hoping that couldn't be 1, 2, 3, but it can. Otherwise, we could have put 3 on this thermo. Can't do that. Right, this number's more than a 5. That's been available since the start. It's now 6, 7, or 8. And we haven't really used the pencil marking on this long thermo at all, which is a bit frustrating, I guess. I don't know. They're not that easy to use, unfortunately. I was wondering where 8 could be, because all of these places and that one have at least 2 more cells to go on a thermo. So I suppose 8 is confined to those 2 spots. No, that is useful because it can't actually be here because that would require a 9 here. So forget 8 being there. Actually, this was a good question. 8 in the central box must be here, and therefore its thermo must end with a 9. That resolves one of our X-wings of 9s. This can't... Oh, hang on. That could have been 8. So all of that is absolute codswallop, and we shall revert to this position, and in fact that... Oh, no. Sorry, that is an 8 candidate. So, sorry, there are 2 candidate positions, 2 possible positions for 8 in the central box, and I was getting ahead of myself there. Now, where can 8 be in box 8? Now that's an interesting question. You would think, it can't be here because that would be 9 and that would clash with that. It can't be here, there's too many left on the thermo, but it can be in those positions, but it can also again be on in column 5. So that wasn't the useful question I thought it might be. Oh, this is not as approachable as Gert's claiming. It's pretty tough actually, unless I'm missing something big time. These thermos just aren't very long. That's the issue here. And in fact, this one was planning to be a longish one, but it ends with a 9, and that hasn't restricted anything on it. So maybe I will fill in the candidates. 1, 2, 3, 4, 5. This can't be a 5 because of the 5 in the row. That 5 is now moved into the box for this one. But I mean, there's still plenty of possibilities even along that, and all the other thermos are shorter. Although this one branches, the one from the star at the top of the tree. So this digit can't be a 9 or a 6 or a 5. Can it be a 4? 3, 2, 1. Yes, it can. And that's not very helpful. In fact, you know, I'm filling in a lot of candidates for those cells now. Maybe... Oh, maybe the thing to do then is to consider where... Yes, okay, well, filling in the candidates has helped here, because now I'm wondering where are 7 and 8 in the central column, and I don't believe they can be in any of these highlighted cells because their thermos are all too long for either 7 or 8. Yes, because even these ones, although 7, 8, 9 would work for that branch, it wouldn't work for the other. Yes, so these two cells are a 7, 8 pair. And that's quite interesting from this point of view. What can this be now? Well, you would think maybe 7 is not ruled out, but in fact, there must either be a 7 on its thermo or in its box next to it. So either way, that can't be a 7, and that's restricting the whole thermometer down to the beginning. Ooh, if I can type correctly. So only 2 possibilities left all the way along that thermometer now. It hasn't resolved whether that is 8. 7 or 8 there. Oh, this nearly becomes part of a 2, 3, 4, 5 quadruple, which would feel quite helpful, but this could still be 6, 7, 8. 7 there, 8 there, 9 there, that's all possible. Crumbs, that didn't sort anything out. Okay, 2 in this box has to be in one of the white cells because it's all too soon along. It would be, sorry, what I'm trying to say is it can't be on the thermo, even that one, because it's too far away from the bulb. Right, 2 is there, so these aren't 2. These aren't 2, that one because of the distance from the thermo. So 2 in box 7 is in one of those 2 cells. Again, this is not quite finishing anything. Right, let's have another look at this central column. So I did the 7, 8 pair, but I didn't notice there's only one position for 6 based on my earlier candidate markings, but I do now. So I'm putting a 6 in there, and that has a big effect on its thermo branches. So 7 there, 8 there, 8 there, and that is real progress. Right, now surely I can make a bit more headway. That 8, no, it does not sort out 8 here at all. It takes 8 out of these as a possibility. That stops this being 7, this being 6, and this being 5. And now there's only one place for 5 to go in the central column, which is proving useful again and again, just as the trunk of a Christmas tree does. 4 must be in one of these positions, and just as we saw with those possible 7s having an effect there, if 4 is in one of those 2 positions, this can't be 4. And that actually... Is that right? Yes. In fact, I could have ruled 4 out of here a moment ago, but I can do it now because this is less than 2 or 3. So as long as I've got my logic right, I'm a little bit nervous about that. 4 in the central column must now be here. And in fact, 3 must now be here. And that allows me to build up this trunk-based thermo that far to a 6 there. Still got a 1-2 pair in the center. That's fine. Now, this 3, 4, and 6, are they? Yeah, 6 in the central box must now be in one of these two cells. If it was here, that would be 7 here, 8 here. That's okay, that works. How about 7 then in the central box? Can't be in those. Oh, it could be here. It could be here actually. Here it couldn't be because that can't be 9, and the same is true for that. So 7 is restricted to a couple of positions in the center. Probably missing stuff now. 4 is confined up here somewhere, just by ordinary Sudoku rules, given those 4s. 5, 8, 4, 9, 1. That can't be 6 either. It's 2, 3, or 7. It would be very interesting if that was a 2-3 pair, but it is possible for that to be 7. That would make this 8. That would make this 8. Oh no. I mean, this is an interesting puzzle. You can get a certain way, but it doesn't give up at that point. It sticks with it. Now, could that be 6? In fact, that has to be 6. Look, regular Sudoku. We've got the 6s in rows 9 and 7, so that must be the one in row 8 in a different box. Right, this, yes, this, I was going to say it can't be 2. Sorry, it can be 2. I don't think it can be 7, because then there's too many to go before there. So that's 2. 7 and 8 are a pair down here. Now I feel like I'm buzzing a bit. 1, 2, although that one is... actually 3, 4 are in the box. Oh, this is a weird naked single. It can't be 9 because that's confined down here. We've got 2, 3, 4 and 6 in the box. 1 on its thermo, 7 up there. This has to be a 5. 8 would be too many because that can't be a 9. So weirdly that's a 5. Now that means 5 is in one of these two cells, and it can't be in that one to reach a 6 there. So suddenly we can place 5 in the middle box. 5 must be in one of those two. Can't be on the same thermo as another 5. In fact, how is that thermo going? 6 or 7 here, 7 or 8 here. That's giving us a 7-8 pair in row 7. The other cells in the row are 2, 3, and 4. 5 in box 7 must be in the corner. And in box 3 in one of those two cells. That is 2, 3, or 4. We still don't know about this 7-8 pair. Right. What about these both? That I've got a 6 pencil mark there, but it's less than 2, 3, or 4. So I can remove that 6 pencil mark. The only place for a 6 in the central box is there. That's the value of pencil marks. This is a 7 or a 9 at the end of the thermo. 4, 6, 9, 5. Do these... Well, they have to be less than 4. So they're from 1, 2, and 3. And that gives us a triple in the center. Those 3 cells must be 1, 2, and 3 because they're all from that population. So this one can't be 2 or 3. It must be 7. The other way of looking at that is this is the last place left for 8 in the central thermo. So that gives us an 8 here. Doesn't resolve this cell. This can't be a 6 anymore. This can't be a 6, which is even more helpful. Although again, only so much is done. This is bigger than a 7, so that is 8. This is very neat the way this is all coming together, piece by piece. Little Christmas jigsaw. That's 2 or 6. 7 there is making that a 9, which doesn't do anything else. It puts a 9 up here because they were on a little X-wing combo. 7, 8. These are resolved by the 7 we just placed. There's a 7 up here somewhere and an 8 up here. We already know about the 1 at the top there. Now, 1, 2, 3, what can this be? It can't be 6, 8 or 9. But it can still be 5 or 7. Not that useful. All right, 8 down here. Look at that 8. That's placing 8 here. Actually, this central thing is all done. The tree trunk is 1, 9 there. That 1 fixes this as a 2. Now we can run that up the thermo all the way. 2, 3, 4, 6. Now we've got a 3 and a 2 to place in box 4. So that gives us a 6 there. We can finish row 5. If I can type correctly, that's a 7. 4 and 5 here. Can't decide those yet. But these aren't 3. But oh yes, there's a 2 down there. So that's a 1. That's a 2. 2, I say. This is not 2. 2 must be one of these cells. Oh, not that one, because we've got a 2 there. So 2 can be placed there. In fact, this one is seeing a 3 and a 2. So that's 4. This is 3. This is 3. We've got a 1 and a 3 to place up here. We know that these are 9 and 4, and we can put them in. 2, 4, 7 still to go in here. A little triple, and that's not a 2, and that's not a 7. Ooh, 1, 2, 4 to place up here. Let's get rid of the 2 from that. This is 8 and 6. Yes, we can do them. That's better. Now that 8, 8, the last 8 in the grid goes in there. This can't be a 4, so it's 1 or 5, which isn't that helpful. No naked singles in row 3 to help. Irritating. That's 1 or 2, because that's all it can be, given everything it can see. That can't be 4. So now we've got a 1, 2 pair. And that makes this one a 3. And this one a 5. And this one a 7. That puts 5 here. That's a naked single 4. Fixes the triple over there. We can finish off rows 3 and 2. 2 and a 7 to place at the top. This one's a 3 now. 5 and 4 are resolved. 1 triple left to do. And another Christmas puzzle finished. A very nice one. Thank you to Gert for that. Little harder than what I would classically call approachable, but very neat puzzle. Really came together nicely. I hope you had a go at that one. That was well worth doing. And as always, do subscribe if you haven't already. Do check out our products, and thank you very much for watching the video and solving that along with me. Hope to see you soon. Merry Christmas and bye for now.